So hey guys, we are now the we are in the organic reaction, the exploring of the world of organic reaction. So first and foremost, welcome to the fascinating world of organic reaction. This presentation will be guide you through the fundamental types of reaction that underpin organic chemistry, from a simple addition to a complex combustions. Understanding these reactions is essential for creating new materials, medicine, and fuels. We'll explore each reaction with clear definition, examples, and a visual illustration to aid comprehension. Get ready to embark on the journey that unlocks the secret of molecular transformation and their impact on our daily lives. Good day, everyone. I am Jigs Arvin Gascon from the grade 11 STEM Sagittarius, and now I am here to tackle you the importance in the different types of organic reaction involving organic compounds. So go and let's start with the first reaction. Addition reaction, or typically known as a building bigger molecules. So the objectives in here is we need to add, yes, because from the addition we need to add a molecule. It's dependable on the situation that we're given. So we need to combine or to add something or or a compound from a previous one that we're given. Addition reaction is being defined as the involvement of the involvement of combining two or more molecules to form a larger moleculars to a large to form a large molecule. These reactions are partly common in unsaturated compounds like alkenes and alkynes, where double or triple bonds are present. During an addition reaction, these multiply bonds are broken, allowing new atoms or group the to attach the carbon atoms, or also known as the Markov-Nilkov's rule, dictates that in addition of the protic acid to an alkene, the hydrogen atom adds the carbon atom with a greater number of hydrogen atoms already attached. So let's remember the key features of it is combining molecules, unsaturated compounds, and using the Markov-Nilkov's rule. So example, the addition of HBr to ethane. Ethane reacts with hydrogen bromide to form a bromothane. This reaction breaks the double bond in ethene, allowing hydrogen and bromine atoms to attach the carbon atoms. So second, we have the substitution reaction, or also known as the swapping atoms or group. Okay, substitution reaction is being defined as the replacement of one atom to a group in a molecule with other atom or group. These reactions are fundamental in organic chemistry and are classified into two different types, involving including SN1 or the unimolecular nucleophilic substitution, and its SN2 or the biomolecular nucleophilic substitution. The SN1 reaction proceeds into two steps involving the formation of the carbocation intermediate, while the SN2 reacts occur in single step with simultaneous band breaking or band formation. Okay, SN1 is remember that the SN1 is a unimolecular or the two-step mechanism, as the SN2 is a biomolecular is also a one-step mechanism. Also, nucleophilic is also known as the electrophilitic or the also known as the or being defined as the reaction of two electrons seeking for an atom or donating a species of atom. Third is the elimination reaction. These are objectified as the forming of two double bonds. So we are tasked that the product of the input compound should be in double bonds, whether it is a single or triple in the start. So elimination reaction involves the removal of two atoms, or the removal of atoms or group from a molecule, leading the formation of double bond. These reactions are essential for synthesizing alkenes and alkynes. elimination reacts can occur via two primarily mechanisms. We have the E1 or the unimolecular elimination, the E2 or the biomolecular elimination. In E in an in an E1 reaction, the leaving group departs first, forming a carbocation intermediate, followed by the removal of a proton. An E2 reaction occurs in a single step, with simultaneous removal or the leaving of group on an atom. So the E1 are the two-step or the carbocation intermediate. The E2 is one step. It is a concerted mechanism, and one of the example of this is the dehydration, removing a water from an alkene. Because we all know that at water is known as being structured as the H2O, wherein there have two hydrogen and one oxygen. If we are eliminating one, so it become alkene with the spelling of ALKNE, or the not it's not ENE because it's now a single bond. So third, we have the oxidation reaction. It is being tasked to increase oxidation number. Oxidation reaction in organic chemistry involve an increase of oxidation carbon number of an atom. These are often manifest as the addition of oxygen or the removal of hydrogen atoms from a molecule. Oxidizing agents such as acidified potassium dichromate are commonly used to facilitate this reaction. Oxidation reactions are crucial in various chemical processes involving the metabolism of alcohol and the synthesis of carbon compounds. Fifth is the reduction reaction, or also known as the decreasing oxidation number. So in the reduction reaction are the counterpart of oxidation, because it is mainly a task of canceling or removing or subtracting the oxidation number from higher to lowest. It is also the counterpart of oxidation, because oxidation is adding, while in reduction is subtracting or deducting. So it's involved in the decrease of oxidation number of a carbon atom. The illustration depicts, and from you can see the illustration depicts from the from the right side if you're facing the monitor. It depicts that the reduction of the keton propanon to a secondary alcohol using sodium borohydrate as the reducing agent. In this reaction, the carbon group in the ketones undergoes the nucleophilic attack by the hydrogen ion, or also known as the H sub negative, provided by the sodium borohydrate. This breaks the double bond between carbon and oxygen, leading the formation of a single OC bond. A photon H sub positive from a solvent, typically water or alcohol, is then added, resulting to the formation of hydroxys group. The final product is a secondary alcohol, specifically propane 2OL, where the okay or also known as secondary alcohol, where the oxygen that was once part of the carbon group is now part of the hydroxyl function group. This reaction exemplifies the fundamental concept of organic chemistry, where reduction involves the gain of hydrogen and the loss of oxygen. Sodium borohydrate serves as the selective reducing agent, effectively converting ketones into alcohol without affecting the other functional groups. This type of reduction is widely utilized in organic synthesis, particularly in the pharmaceutical and fine chemical industries, to provide alcohols with high specificity and efficiency. We have the last combustion reaction, also known as the burning of energy. Combustion reactions are the exothermic chemical reaction that involves the rapid reaction between a substance with an oxidant. Usually it is oxygen, mainly oxygen, to produce heat and light. These reactions are fundamental in energy production, where fuels are burned into thermal energy to generate thermal energy. The product of a complete combustion are typically hydrogen dioxide or no, I mean sorry, rather carbon dioxide and water combustion reaction are balanced to ensure the number of atoms of each element in the same both side of an equation. So first step is the reactants, wherein the reactants is the fuel and oxygen based on the definition. Second, their reaction, the fuel and the oxygen react to the rapid oxidation with the heat and light. And third is the product of the reactants, wherein the reactants are fuel and oxygen. So we have a carbon dioxide and water. So organic reaction types a visual summary. To consolidate and our understanding, the card provides a visual summary of the different uh, organic reaction where types we've covered. The diagram shows the transformation of key key reagents involved in each reaction. The visual representation aids the memorizing of the differentiating between addition, substitution, elimination, oxidation, reduction, and combustion reaction. Using the summary as a reference to quickly recall the characteristics of each reaction type of the application. So we have the first addition, second subtraction. It is linear. Actually, it is first layout of this is being linear, but I decided to make it a double column since the space will not being utilized on the capacity on the screen. So I will just explain it to you how it become a visual summary. So we have the addition. It's being followed. No, it's being followed by the substitution because substitution and addition are the opposite. So they should be uh tapad or ano sa hindi siya tapad basta ano siya. So the second is substitution and elimination. Oh, we all know that substitution and elimination are the opposite also because you are eliminating or you are removing while in substitution you are changing. Second is the elimination and oxidation. So typically I that's why I I moved the for the other three side in the second column because they are not lineage or they are not linked between elimination and oxidation. So oxidation and reduction are the opposite or the counterpart of each cell, wherein oxidation is increasing while in reduction increasing the oxidation number. And the combustion is the type of process wherein you are burning the fuel and the two reactants you are burning the two reactants for you to able to provide an product. Third, real world application of organic reactions. You can do it in your in pharmaceuticals, polymers, and the food chemistry. The actually this it is uh nowadays it is five a need and relevant to our nurses in other sectors of medicine because I think reaction of this organic one are really mainly in need or essential for us to develop our initial innovation and thank you. So last we have the conclusion of the mastering organic reaction. So we are know that there are six types which is being covered as the addition, substitution, reaction, elimination, oxidation, reduction and combustion. So that's all I think. As we further, I actually encourage you, us and all the students to continue exploring the world of organic chemistry, as further study in this area is highly valuable and rewarding to our government. Thank you. Bye.